Hello and welcome, dear friends. Today we'll be discussing about the implementation of the event study and the value at risk models using R. And we'll take the case studies from the Indian financial market. In the previous classes, we have discussed about the theoretical framework of the event study analysis, also the value at risk models. Today we are going to see that how we can use statistical software R to implement those theories in case of Indian market. So let's quickly lay out the today's plan. So first, let us quickly revise what is the event study. In event study, basically we try to find out what is the market reactions of significant events. In this lecture here, the objective is basically to analyze the impact of the two major events on the Indian stock market. And we have discussed that in the theoretical discussion also. The steps which we follow to conduct event study analysis are that first we identify the event, second we define the event and the estimation windows, then we calculate the abnormal returns, then we also calculate the cumulative abnormal returns, then test the null hypothesis whether these abnormal returns are different than 0 or not. And based on that we make the decision whether the event has significant impact on the returns or not. Here the key metrics which we will be using, that is abnormal returns and the cumulative abnormal returns. Here we'll analyze the two events. First will be the corporate announcement, that is the merger announcement by the Reliance Industries, where we will be having the event window 10 days before and after the announcement. And the estimation model will be using the market model. So we have discussed earlier in the theoretical discussions, there are the different models we can use to estimate the normal models. Here, normal returns. So here we will be using the market model to estimate the normal returns. The second study which we are going to see is the global event, that is the COVID-19 pandemic, and due to which Indian government has announced in March 2020 a complete lockdown. So how does that affected the market? And to see that, we will be using two indices, one the Nifty 50, which is overall market representative of the Indian financial market, and the sector analysis, where we will be using the IT industry to look how it has affected. Then the next case study will be discussing about the value at risk. So what is the value at risk? It is a measure of maximum expected loss for a portfolio at a given confidence level. We have discussed the different applications of the value at risk. Here the objective of this lecture is that we will analyze the risk of a sample portfolio of the Indian stock market using the value at risk models. So the steps for the conducting this value at risk study is, first we will choose the portfolio, then we'll collect the historical price data, then computing the daily returns, then we calculate the value at risk using all three different methods which we have discussed, that is parametric, historical and Monte Carlo methods. Here the key metrics which we'll be using to make the decision, that is the confidence level and also the time horizon we'll take. Here again the data source basically will the historical price data. We can download from either the NSE website or using the Yahoo Finance. The study time period will be January 2010 to January 2024. We'll be using that. Then we'll be using historical vector value at risk method, so which already we have discussed in the detail. Then we'll be using the parametric value at risk method, where we have the formula which we have already discussed, that is we'll take Z multiplied by sigma P into square root of T multiplied by portfolio value, where the sigma is the standard deviation of the daily returns or the portfolio, Z is the critical value from the standard normal distribution, T is the time horizon or the holding period, portfolio value it is easy to understand by the name. The first will estimate the standard deviation from the historical returns, whether of the individual stock or the portfolio. Then we'll use the Z value, either the 95% or the 99%. So at this confidence interval, we know that it will be either minus 1.645 or it will be minus 2.33. Then we'll interpret the results as the maximum loss at the given confidence level. Then similarly, using the Monte Carlo simulation, we will be estimating the value at risk. So these are the steps we will be using. So now let's go to the R studio, which we are going to use to conduct this particular case studies here. So as we have discussed in the previous lecture also, here the process is that we'll make a project folder and we'll open that project folder. So project folder here is the week 12 case studies, and there we have the script file. We'll be using those script file to conduct this particular studies. So let us first talk about the first case study about the event study analysis. So here we have this first case studies on the event study analysis. So here this file have all those the commands or functions which we will be using to conduct this study. Then again, here we have this message which basically reflects that there are the certain packages which is going to be used in this particular study or in this particular module, which is not being installed in this particular machine. So what we do, we'll first install those by clicking here install. So once we do the installation, so it will install those packages. Then here we have I have written the details of this study. So first here these are the informations of this, which is basically not necessary. It is optional. If you wanted to write your details, that you can write, otherwise you can skip that. Then the first step is installing and loading the required library. So already we are installing those libraries. So either we can install directly or we can use the command by making active. So once we delete that hash mark, so it becomes active. So however, here we are installing through the window. So I'm not going to use the command line. So once these packages are installed, then we'll be loading those libraries using the function libraries. So let us install it here. Then the first will identify the event, then event date. So those steps will follow one by one here. So here we can see the libraries are there. Then we have the how to define the event and the estimation window and the collecting the required data. Then we'll transform those data because we'll having the price. So we'll transform that into the returns. Then we'll calculate the normal and abnormal returns. Then ultimately we'll fit the market model to calculate the normal returns. Then we'll find out the alpha and beta of those models. Then once we calculate the normal returns, then we'll be calculating the abnormal returns. So once we have calculated the abnormal returns, then we'll see whether those returns are significant or not. So basically we'll be using the significance test or the null hypothesis testing for the abnormal return. Then based on the t statistics, we will make the decision whether the events are significant or not. So all the required packages has been installed now. So let us attach those using the function library and the package name here. So the library, the first, the quant mode. So that have been attached. The next is the tidyverse we attach. And third package, the library performance analytics, we are attaching that particular package here. So once we have attached those required packages, the next task is first identify the event date, event window and estimation window. So here event date is the corporate announcement, merger announcement by the Reliance Industries. So that happened on 8th November 2020. So that's here event date. As date, I'm recording this particular as the event date here. So once we execute this command, so here we can observe that that particular object has been created which stores the information about that particular date here. Then now we are creating the event window. that is 10 days before and after. So here event window is basically that is 10 days. So we are storing that information in the object event window, and the 10, that is the 10 days before and after we are adding. Then the estimation window. For the estimation window, again we are creating here 60 days. That means before and after the just we are having the event estimation window, that is the 60 days period we are using as the event window. Now once we have defined event date, event window and event estimation window, now we are going to download those required data here. So here we are downloading the stock prices of the Reliance, and for the market model we are taking the reference is Nifty 50. So the get symbol, so here the get symbols is the command through which we will be collecting the data. Name of those tickers here we have. Source is the Yahoo Finance from 1st January 2020 to 31st December 2020. We are taking that. So now let us take this here. So once we have downloaded the data, here you can see both this we have Reliance. So once we click on there, so here we have the all those informations stored here. So the first is basically what we have, the opening price. Second is the high for that particular day. Low is the lowest of that particular day. Close is the closing prices. And this is the volume, how much it has been traded. This is the adjusted price. Adjusted price we already have talked, adjusted for any dividend, any stock split, for anything it is being adjusted here. Now once we have calculated, downloaded, similarly we have for the Nifty 50. So here again what we have, the opening price, high for that particular day, low for the particular day, and the closing and the total volume traded, and this is adjusted price here. Now once we have calculated those data, now we know that we are not going to use the prices, rather than we are going to use the return. So let us calculate the return. So here we are taking the adjusted prices of the stock price, and we are getting the market prices. So we have taken the adjusted prices of the Reliance, adjusted prices of the market in the Nifty 50, which we have stored as the market price. And stock price is basically refer that particular company, that is Reliance here. Then we are computing the daily returns here. So we have calculated the daily returns here. Now let us plot those here. So to plot that, what we will be using, we will be using the command chart. Or we can use the plot. So plot we are using, so that is the stock prices. So we are using the stock return. So let us execute this command. So here we have this stock return here. So what we can observe here, that if you see here the March 2020, so there is the quite fluctuation here we have in the return. So it will be better understood if we take the, rather than return, let us plot the prices here. So let us plot this. So here you can see in the March here, so it is the March, so here we can say April is starting. If you see the March 24, there is the huge decline in the stock prices of this Reliance here. So we can say when there is the announcement happen, there is the quite impactful event we have this. Now let us see in case of the market prices. So plot will use the market price. So if you see the market price here, there is the again jump. This was the basically lockdown effect we have. So let us now calculate the normal and abnormal window. So now the normal window, so that is estimation. So see what we have done. We have done that estimation and event window. Now what is the when it is starting, so that we have will take here. So estimation start, that is starting point estimation window is the event date minus the event estimation window, that is the 60 days before we are taking. So here we are taking the estimation window which we have created here, that is what we have start. So it is starting on the 9th of 2020 here. So to understand that, let us take here the graph here. So here we can see here that September of 9th, from this point we are having the estimation window. Then similarly estimation ends here, that estimation ends so here we can say the estimation ends on 28th October 2020. Remember here the event window we have November. So before that it is ending here. Now let us calculate the, so here basically we are making that data for the estimation window. Now once we that, now we are making subset of the data to be used for the estimation of the normal return. So here estimation for the stock. So basically in that what we are having stock return. So the reference point is the stock returns. What period we need? The index basically refers the particular date, then the stock return. It should be more than the estimation starts and less than the estimation end. So in between we are basically making the subset of that. So the estimation stock we are making subset here, this. So if you see here the estimation stock, this is the we have created. So this is subset for the estimation we are using starting from 9 September 2020 and ending at 28th October 2020. So this is the data which we'll be using to estimate the normal returns. Similarly for the market we are creating. So for the market we have created estimation market. So if you see here the data, again the same 19th September 2020 till the 28th. So this is to create the normal return. We have calculated this. Now let us fit the market model here. So what is the market model? Okay, that estimation of stock depends on the estimation of market. That is that Reliance stock we are forecasting the expected value of that, assuming that it depends on the market performance. So that's the basically we are doing here. So basically here we are using that the Reliance stock, it is the function of the market return. That is the concept we are using here. So we are estimating here the Reliance stock, the returns of the Reliance stock is alpha 0, alpha plus beta into the market return. So the market return we are taking Nifty 50. So that's model we have using. So through this we will be take the expected value of the Reliance return, or what we can say, this is nothing but we have defined as the normal return in case of event steady analysis. So the normal return, we are using the market model to calculate that. So that's what we have done here. So fitting the market model here. So once we fit the market model, so we will have here the market model is this. So here all the coefficients fitted value we have calculated. Now once I have calculated, let us get the coefficients here, alpha, beta. So the basically the coefficients here, this we have calculated. Now using those we will calculate the abnormal returns here. So abnormal return, to calculate the abnormal return, we'll use the event window. So here we are putting that starting date for the event and ending an event. Then again creating the event stock and event market. So let us say the event stock here. This is the window, 10 days window we are taking for the event stock here. So once we calculate the event stock, so what we are doing now, we are calculating the expected return. So how we calculate the expected return? So basically to calculate the expected return, we have used the market model. So once we run that, we will get the estimated value of alpha, estimated value of beta. Then we'll find out the expected return of the Reliance stock using this alpha estimated plus beta estimated and using the Nifty 50 of that particular day, return of the Nifty 50 of that particular day. So we use this to estimate or to predict the value of Reliance return. So that's what we are doing here. The expected return here, we are using this. So we calculated that. Then now we are calculating the abnormal return. How we calculate the abnormal return? That actual return minus the expected returns. That's what we are going to use here. We know that abnormal return is nothing. Abnormal return, you may recall from the theoretical lectures, that is the actual return minus expected return. We have calculated the expected return using this market model. This already we have. Now we are calculating the abnormal return. So abnormal return we are calculating. So this. So once we calculate the abnormal return, that is for 1 day. Now what we have to do, we have to find out the cumulative abnormal returns. See, this is the abnormal return. So this is for all the 10 days we have calculated, because event window is 10 days. Now we have to find out the cumulative abnormal return. So we use this function cumulative abnormal returns, and here use the function cumulative sum, and the short is the cum sum. Then abnormal returns, the data we are referring here. So let us calculate the abnormal return here. So we are calculating the cumulative abnormal return. So here you can see the cumulative abnormal returns is this. Now once we calculate that, let us visualize both these abnormal returns and cumulative abnormal returns here. So first, so here you can see these are the abnormal returns around the event. So that 10 days event window here we have. So this is the abnormal returns around this event window we have. So this is the 0 and these are the abnormal returns we have. Similarly, let us calculate, plot the cumulative abnormal returns. So here we are calculating. So this is the cumulative abnormal returns we have for this event window. So now what we have done, we have created both abnormal returns and the cumulative abnormal returns. Now we have to test that whether these are the significantly different from 0 or not. For that, what we are doing, first we are find out the mean of the abnormal return, standard deviation of the abnormal return, and the number of observations of abnormal return. Then we will be using those statistics those informations to create the T statistics. So let us first calculate the mean of the abnormal return. So here we are taking mean. This is the name of that, and here we are taking the function mean of the abnormal returns. Here we are taking this. So similarly, we are calculating the standard deviation and the total number of observations we are creating here. Then we are calculating the T statistics. So this T statistics. Now we are testing whether the abnormal return is different from 0 or not. So perform the one sample T test. So here we are having this one T test here. Now let us see what basically we are getting result. So here we can say the mean of abnormal return is this, and standard deviation of the abnormal return is this, and the T statistic is this, and the P value is this. So if you see here, so we have calculated the mean of the abnormal returns, standard deviation of the abnormal return here, and the T statistic of this, and the P value is this. Now the P value, it turns out to be 0.5534. So what basically it means here? So we have the null hypothesis. We have the null hypothesis as that abnormal returns is equal to 0. So the P value we have 0.55. Now the rule is this: if if the P value is closer to 1, that means accept the null. If P value is closer to 0, that means reject the null. And here obviously the P value is closer to 1. That means we are accepting the null. Accepting the null means the abnormal return statistically is equal to 0. If it is that, that means what we will have this, the fail to reject the null hypothesis. That means abnormal returns are not significantly different from 0, and the interpretation of this, the events of the merger does not have significant effect on the stock prices or the returns of the Reliance Industries. So the event is not a significant event. However, this is based on the abnormal returns. So let us take the second measure of the abnormal return, that is the cumulative abnormal return. So in that case, now we are creating the mean of the abnormal return, standard deviation of the abnormal return, and the length of that. Then we are calculating the test statistics, then performing the test results. Then let us see all those returns here. Now what we can observe here, the mean of the abnormal return is negative 0.03, standard deviation is 0.033, and the T statistics is minus for 1.216, and the P value is 0.0013. So what we have this, that mean of cumulative abnormal returns So here the mean of cumulative abnormal returns is minus 0.036, and the P value is close to 0.00. So that means based on this and this principle, we reject the null. So rejecting the null hypothesis means the event has significant effect on the cumulative returns, and it has a negative effect. That means the announcement of merger has negative effect on the performance of the stock returns of that. So let us again check it here that this. So reject the null hypothesis. That means cumulative abnormal returns are significantly different from zero. That means though at the abnormal return it does not have the significant effect. However, while we are calculating the cumulative abnormal returns, the event has significant effect on the returns. So that is the first case study we have done, where we have seen that what is the effect of the announcement of the merger of the Reliance Industries on the stock of the Reliance Industries. What we have observed that if we are relying on the abnormal return, there seems no significant effect. However, when we are using the cumulative abnormal return, we observe there is a significant effect on the return, and that is a negative impact on that. So that's how we can observe if any event happen, what is the how it is going to impact on the returns of a particular stock here. Now let us take the second case study of the event study. So before that, let me clean here all those results which we have got here. So we can clean this, and even the console we can clean using the control plus L on the keyboard.